Okay, everybody make sure you have these notes in front of you and put your name at the top. Today we are going to recognize proportional relationships. This is going to be a super quick and easy video. I'm going to try not to put you all to sleep like I did today in class. Okay, the only thing I want you to be able to do by the end of this video is be able to recognize if a table or graph is a proportional relationship. So when we're looking at graphs, there are two requirements. The points must lie in a straight line. Oh, that seems pretty easy. Okay, check. Look at both of these graphs to the right. Are they both straight? No, not straight. This one cannot be proportional. Also, it must pass through the origin. The origin is that little corner in the middle. This is the origin. This does not pass through the origin. Does not pass through origin. Let's do this test on the first one. Is this a straight line? Yes. Straight. Straight. Oh my gosh. Passes through origin. Beautiful. This is proportional. This is not. Make sure you have this. I'm going to scroll on down. Sometimes we have to look at tables. In this situation, all we're going to check for is that all the ratios are equivalent. That's why we just spent a couple of days talking about equivalent ratios. The multiplier must be the same. So for example, if I go from cats, which is 2 to 4, I multiplied by 2. From 2 to 6, I multiplied by 3. From 2 to 8, I multiplied by 4. Let's see if that's the same at the bottom. Multiplied by 2, multiplied by 3, multiplied by 4. This looks proportional. This is not proportional. I multiplied this by 2, multiplied this by 3, multiplied this by 6, multiplied this by 3. Those are not the same. This is not proportional. So far, pretty easy, right? Okay, this time I have some helpers to help me. Number 1, Rocco. What do you think about number 1? Is it proportional? What are the two things we're looking for? It has to be
on the origin.
On the origin. It is on the origin, so that's good. What else does it have to do? Do you guys remember from the videos I just made? It has to be straight.
Oh. No.
Is that line straight?
No.
No, so put a big N-O there. Anybody else want to come up? Come on, Nate. Nate, what do you know about number 2? Is it straight?
Yes.
Yes, it's straight. Does it go through the origin? Where's the origin? Yeah, does it go through the origin?
No.
No, it's not proportional, right? N-O. Beautiful. Anybody else want to come up? No? Or, okay, Rocco, is this?
This is.
Why is this proportional?
Because it's on the origin and it's straight.
It's both. So what are you going to write there?
Yes.
Yes. Beautiful. Tell us nice and loudly again, why is this one proportional?
Because it's on the origin and it's straight.
It's straight and it passes through the origin. Very good. Okay, we're going to pause the video. Make sure you have this. This time we're looking at tables again. Determine if each table represents a proportional relationship. Explain your reasoning. Well, we multiplied by 2 here. Then we multiplied by 3. Then we multiplied by 4. Let's see if those relationships are the same. Multiplied by 2. Multiplied by 3. Multiplied by 4. That looks pretty good. The other way we can look at it is we added 5. We added 5, we added 5 the same time, we added 6, we added 6, we added 6. So it's going up by the same amount every single time. This is going up by 1, this is going up by 5. This goes up by 1, This goes up by 7. Uh-oh. This goes up by 1. This goes up by 9. That does not seem like it'll be right. So this is times 2, times 3, times 4. This is times something crazy. 2.5, I think. But not times 2, not times 3.5. So this is not proportional. Okay, Rocco, do you want to help me with this one?
Yes.
Sure.
So
Okay, write that in there. That's one way to look at it. Very good. Rocco notices if you multiply the hours times 5, we get the number of miles. Does that work for all of the hours? Let's try it. What's 12 times 5? Does anybody know?
60.
60, right. So that worked. How about what's the next number? 14 times 70. If we put it in our calculator, 14 times 5 is 70. And 16 times 5 is 80. Is that right? Yes. So write a big fat yes there. Nice job, and our video is over. Whoops. Harder than it looks, isn't it? Beautiful work.
This is fun.